Hello, Mr. Ricardo. Thank you very much for accepting our invitation, and I'm very honored to have you here in our podcast. As we have already discussed, today we are going to talk about how to validate qualitative test methods. I think it's one of your areas of expertise, and I hope that we will have a good discussion. First of all, may I kindly request you to briefly introduce yourself and provide us with some information about your experience and background in the field of analytical chemistry, laboratory accreditation, or similar areas?
Okay, so first of all, I would like to say that the honor is mine. So thank you very much for the invitation. I already saw some of your videos, and I think that you are doing an excellent work in disseminating all these discussions about very important topics. And I'm happy to have this talk with you about the qualitative analysis. Okay, my background. So I'm from Portugal. I am graduated in chemistry. Then I completed my master on food quality control and toxicology, and the PhD on analytical chemistry. Both the master and the PhD were focused on metrology in chemistry. And I have completed these two academic levels as an analyst in a full-time job as analyst. So I had to somehow do my routine analysis, and together I used information from the lab also to complete the master and my PhD. To complete my description of my background, let me tell you that I have, I would say, 4 years of experience as a routine analyst in organic analysis, and 9 years of doing the official monitoring of pesticide residues in foodstuffs. So I have experience in both inorganic and organic analysis, and since 2002. I'm a technical assessor of the Portuguese accreditation body, with more than 200 external assessments as technical assessor, so which allow me to understand how difficult it is to implement the standard and to do business on this analytical chemistry. In the last 10 years, I started to work at the University of Lisbon as a researcher, doing teaching and research on metrology and what I usually call examinology in chemistry. So metrology is the science of measurements, and examinology is the science of qualitative analysis. That will be the topic of our discussion. Yes.
Okay, thank you very much for the introduction. My first question is that for the beginning, may I kindly request you to briefly describe how method validation should be performed for qualitative analysis? I mean, in terms of what performance characteristics need to be evaluated and considered in such studies.
Okay, so the qualitative analyses are rather diverse, I would say. We have many different types of qualitative analysis. If you want to identify the presence of a compound in a complex matrix, and you report if it is present or not, or not present above a limit, you have a qualitative analysis. Even the comparison of a measurement result with a limit value that result in reporting as conform or not conform with the legal limit is somehow transforming a measurement in a qualitative analysis. And typically, when we have this type of analysis, first you have to define what you call a positive or a negative result. Okay, this binary result is typically people classify them as positive or negative. You should clarify clearly what it is a positive for you. For instance, if you identify cocaine in the urine of an athlete, you can call it a positive because it is present, not because it is a good outcome, of course. And the negative, by convention, you can say that there is no evidence of the presence. Okay, so but you can also do it, define the conversion in the other way around, no problem. But okay, but when you have a positive result, typically you would like to know what is the chance of that procedure producing a positive result when the case or the sample or the item is in fact positive, I would say. So we have to know, we have typically calculate know the rate of true positives and the rate of false positives. The rate of false positives is the chance that given a negative case, that the procedure reports the result as positive. And of course, in many cases, or in some cases, you will also report a negative result. So you also need to know the true negatives and false negative results rate. So to summarize, the performance characteristics that you need to know are the rates of true and false results. And if the performance of the analysis depends on the level of the property, imagine the concentration of analyte, you must know how this performance varies in the analytical range. Okay, and then you will get a limit of detection that will be the minimum level of that property that you can report as positive in a reliable way. So, okay.
Okay. Sometimes in qualitative analysis, the result is a binary result, positive or negative, detected, not detected. But sometimes the result might be in a range of probable results. I've noticed that in Iran, we have many petroleum and petrochemical companies, and in one of their tests, I've noticed that there are some color codes that they identify these codes, but it's a qualitative analysis. No value is generated, or there is no quantity for which a number should be assigned, a value should be assigned. Is there any difference in how we should proceed with method validation in these two cases? In one case, we have only a binary result, true, false, positive, negative. And in other case, a range of results might be possible, and sometimes the difference between them might not be very significant. Is there any comments about this?
Can you give me some more details about this petroleum analysis? Because so you report as a range of values. So
they report something like 1F, for example. 1F is a classification of a certain color based on a test that they have. And this is reported. Sometimes it might be 1G. For example, in the ASTM test method, it has been specified. But sometimes in microbiological testing, you look for a certain microorganism. It is either present or absent. There is no other result.
Okay. I imagine that in this petroleum color scale, some scales are closer than others regarding the color intensity. Yes. Okay.
Exactly.
Okay. This is an example of more ordinal scale. So we have a nominal property, you have an ordinal scale, and then you have the continuous scale, typically from quantification. So in these type of situations, in these ordinal scales, and a very common example is the Mohs scale, scale. In this case, we have a rather strange thing, because it is not a quantitative property nor a pure nominal property, because you have a number or a scale where we have different classes, and each class is closer to a neighbor then to another class. So if you miss the identification or the classification to a closer class, is not as bad as missing a classification to reporting something that is rather different regarding the closeness of property intensity to that class. So, but in this case, our life is a little bit difficult because typically that scales, the difference between the two scales can be not constant. Imagine the difference between the first and second scale can be closer than between the second and the third scale, which make more difficult to express in the quality of our identification information about the closeness of our classification. So in this case, at least in the EUROChem working group, we are not working at this stage in this type of situations. When we have an ordinal scale, we try to look it as a nominal problem. Okay, imagine if you have hardness scale 7 to be tested. So we have an item with hardness scale 7. We only check the true result rate, or for us, we have a true result when we report 7, because the reference is 7, and we don't distinguish if we report 8 or 10, because we assume that both of those cases are fails. Although we know that 8 is closer than 10, to 7 than the 10. So to summarize, I would say that the example that you just reported is the management of an ordinal scale that is not a measurement, I would say, or not a conventional measurement, I would say, and it is rather different from a pure qualitative analysis. It's something in between that is more difficult to manage. Let me tell you another thing. As I know, the group that is producing the next edition of the VIM 4, fourth edition, plans to include the nominal properties determinations in the concept of measurement. Although there is not this continuous meaning of the scale, you know, but some people are not very comfortable with that, with putting ordinal scales in the measurement concept.
You mean that performing method validation for these semi-quantitative parameters are more complicated than pure qualitative or quantitative analysis. Am I right?
Yes, but the term semi-quantitative is not the best term for that, because usually we use the semi-quantitative when we have a measurement with, I would say, with a large uncertainty, something like that. Yes, these scales are difficult to manage, because the distance between the scales is rather different. So I think that anything that you can do with that distance will be, I would say, debatable, will be more difficult to be consensual. Okay.
And the terms you mentioned, false negative rate or false positive rate, I think cannot be applied for such situations. Am I right?
No, we can use it. We can use it. If for us, imagine if you have a reference, if you know that item is class 7, and then you test your procedure. If you get 7, it will be a true positive. Okay, if it is 8 or 10, you can assume that it is false, and you don't put in your model, in your assessment, the closeness of the false results to the scale, to the reference scale, to the reference value of the scale.
Okay, thank you. My next question is about a controversial term, measurement uncertainty. I've noticed that many accreditation bodies exclude qualitative testing from measurement uncertainty, and they say in their policies that laboratories are not obliged to quantify or estimate measurement uncertainty. And also the definition of the term in VIM, it is emphasized that there should be a quantity and the value should be assigned for that quantity. And in that case, we have measurements. Based on this definition, can we say that measurement uncertainty cannot be applied for a qualitative test since there is no quantity exists?
You cannot use the word measurement for a qualitative analysis. Yes. So this is a very nice question and interesting topic. So if you check the VIM, it is stated that yes, the measurement is only applicable to a quantification, and when you determine a qualitative or a nominal property, the word or the term should be used is examination. They use examination. Okay. In some references, they use examination both for measurements and for qualitative analysis. So something more general. But if you check the VIM, they decide to use measurement for quantifications and examination for the determination of qualitative analysis. Some years ago, I don't know, there was a project, an important UPAC project, that developed a vocabulary for determination of nominal properties. They call it VIN. That is somehow it is the VIM, but applied to qualitative analysis, where they have the parallel of I would say most terms from the VIM to measurements, but applicable to qualitative analysis. So they have examination uncertainty, examination traceability. They have all of that. Okay, so this means that we cannot use the term measurement uncertainty for qualitative analysis, but we can use examination uncertainty. Okay.
Examination. Okay.
And like I said to you, according to the information that I have for this working group that is developing the 4th edition of the VIM, they plan to add to the measurement concept the determination of these ordinal properties. But qualitative will be something separate, clearly separate, different. And it is interesting that nowadays everybody somehow faced or got information about the performance of qualitative analysis, the COVID tests, the sensitivity and the sensibility that are ways of reporting the true and the false result rates. And so this concept is becoming it is obvious to everybody that the reliability or the uncertainty of qualitative analysis or examinations is very important.
I think that if you want to use or apply uncertainty for these qualitative testing, the uncertainty should be based on these false positive and false negative rates. Am I right?
Yes, yes. The things can be the easy way to report the quality of a positive result is to report, okay, the result is positive, and then you report the true positive rate and the false positive rate. Okay, this is the easy one. so people can understand, can know from that reporting how good it is, the qualitative analysis procedure. Okay. But this way of reporting is not perfect, because when you report a true and a false positive rate, you express only performance, I would say. You are not expressing the probability of your positive result being in fact true. This means that if you want to report your result in a more sound statistical way, okay, to summarize, you know to have prevalence information. You must know you must have some prior information about the studied population. Let me give you an example. If you have a COVID positive result, if you have imagine that you have a positive result from a COVID test, fast one, that ones that are cheaper and faster ones, and if the person from which you took the sample for the analysis is from a country or a population where there is a big incidence of COVID. So imagine 50% of that population we know from our prior knowledge that is infected. That positive, the probability that positive being correct is larger, higher, if you get the same positive from a population where you know in advance that everybody is vaccinated and the prevalence of the COVID is low. And there is a very nice statistics from Bayesian theorem, easy to follow, that explains you how you can jump from performance parameters to more direct, specific information about your sample. So things can get more complex, but also more useful.
Very interesting. Thank you very much. One of the typical performance characteristics which is used in quantitative test methods when we validate a method is bias. But I assume that determination of bias and evaluating the bias for qualitative methods is rather difficult, or sometimes it's not possible to do it directly. And some experts believe that when you calibrate your equipment, when you evaluate the competence of your staff, and you have the records of successful participation in proficiency testing, we can indirectly conclude that there is no significant bias. But direct determination is not possible. May I have your comments about this?
This is a difficult question, yes. If you check that UPAC vocabulary for nominal properties, they define examination bias. They define that examination bias. And if you check that their definition, it is more applicable to the definition of that ordinal properties. Okay? Well, this is a way. So this question somehow. These questions somehow allow us to discuss previous questions that you mentioned about how to deal with the ordinal properties. Okay, so what they say is the following: if you have a reference method procedure, or if you know in advance that that item has the class 7, yes. If you test that several times, and if by using procedure 1, and if the results from procedure 1 are always 7, there is no bias, of course, from your determination of nominal properties. But instead of 7, if it reports 8, the bias will be 2 regarding this ordinal scale. If it is reported 9, the bias is even larger. So there is some, I would say, some use for this concept for qualitative analysis, but it looks to me that it is more useful if you use it for ordinal properties than for pure nominal properties. Yes, but yeah.
In ISO 13528 standard, which is used by proficiency testing providers as a reference for statistical techniques, there is a section for how to evaluate the performance of participants in qualitative test methods. And one of the methods defined in that standard for determination of assigned value is expert consensus. My question is that, can we have a similar approach in assigning a value? A value is not correct. Assigning a certain, I mean that to make a reference material or have a reference in order to compare on performance against that when we validate a qualitative test methods in the laboratory, or not?
Yes, I think so. But look, in the example that you mentioned, I would say it can be more useful for analysis like sensory analysis. Let me give you an example. One of the problems of qualitative analysis of rather complex items, items that are so complex that it's difficult to produce them by formulation. Imagine if it can be difficult for us to produce a food product contaminated with a pesticide, with an incurred pesticide, that will be as challenging as we would like for our identification method. Okay. If we have something like that, typically to get the false and the true result rates, we must rely in a tool to transform that real item or to give a reference value for that real item. Okay, typically we should use a more selective method than the method that is being tested. Imagine if you use ELISA test for pesticides in foods, a good reference to set the reference values could be GCM SMS, because it is more selective. Okay. Okay, but if you want to assess the performance of your GCM SMS, probably you don't have a better reference than itself. Okay, but coming back to your problem, if we have a sensory analysis, imagine detecting a defect in wine by through sensory analysis. I would say that the only way to get adequate reference is to have the output from a group of experts that check the wine for its defects. So, but I would say in instrumental chemical analysis, this expert judgment is more difficult to use, I think. I would say.
Okay, my next question is about how accreditation bodies should see qualitative test methods in terms of method validation, quality assurance activities. Mainly, they are focused on how to validate quantitative test methods or how to estimate measurement uncertainty for that. And they are not very strict about qualitative test methods. And some aspects like metrological traceability, method validation, measurement uncertainty as mentioned are not applicable as much as qualitative test methods. Based on your experience in accreditation, what is your idea? Do you think that there should be a certain policy to clarify how much laboratories should do for qualitative test methods, and these policies should be as clear as possible for them?
Yes, okay, I agree with you, yes. The accreditation criteria are not as strict for qualitative analysis as for measurements. There is a ELAC policy that tells us that labs are not expected to report the uncertainty of qualitative analysis, okay, but they must use valid qualitative procedures. So in theory, so in fact, they have to prove that their qualitative analyses are valid, so the rates of false results are low enough. And the same philosophy is applicable to a measurement procedure. So typically, you must set a maximum false result rate and prove as much as you can that the performance or that the observed false result rate is lower than that limit. Okay, you have to do that. But in fact, in most labs, they try to use what they call safer approaches to deal with their qualitative analysis, to be on the safe side, to avoid reporting false positive results of the false presence of analytes. But in some fields, they have strict rules how to define what is a positive or a negative result. For instance, in pesticide residue, in the analysis of pesticide residues in foodstuffs, that tells you how many ions you should use. They define tolerance for the ion abundance ratios. They have the same for doping analysis. The World Anti-Doping Agency also define criteria exactly how to report a result as positive. So they have criteria, very strict criteria, but there is always a but. In many areas where there is no such criteria or such defined rules, we have rates of false results much higher than we would like. So there are areas where things are not under control, and even in cases where we have heavy regulations regarding how to report, how to use information for our qualitative analysis, like in WADA, they have very strict rules, but that rules are done in a way that are not, in many cases, adapted to the real performance of the lab. So in that situation, you have cases where you have high rates of false negatives. So we have done a work, we have published a work recently where we proved that if you follow the WADA guidelines to identify doping substance in urines, in some cases the criteria are so strict to avoid false positive results that you can have rates of false negatives around 40%. So to summarize, accreditation is not asking as much as they ask for measurements, because they feel that the state of the art is not stable enough, consensual enough to allow labs to report the uncertainty of qualitative analysis, but this gap of knowledge of harmonized criteria is a problem in many fields, and we need to invest in improving the quality of qualitative analysis.
Okay, so you agree with me on this point that they are not very sensitive about qualitative analysis compared with quantitative one.
Yes, but look, but they do that because they feel that if they ask something that is not available there, so imagine they for sure some of them believe or that in some fields the rates of false results are much higher than we would like, but they feel that there are no tools available or there. State of the art is not developed enough to allow labs to solve that problem. And accredited labs, we don't expect them to do fundamental research. They must rely on the state of the art, and their mission is not to move the state of the art, okay, because it will be too expensive for them, difficult to handle. And although I would like to have a better status of qualitative analysis in accredited labs, I agree that currently the approach of the accreditation bodies is I would say the adequate one, realistic one. But I believe that things can improve in future, near future, I hope.
Thank you. My last question is that I know that you're working on publishing a document about qualitative methods validation in one of your EuroChem working groups. But is there any guides or documents that you suggest which might be useful for the labs to help them in validating their methods for qualitative testing?
Okay, so we have some documents, some rather old works on this area that we could that I could mention, but I think that in the next weeks, I hope it will be published. The first it will be published an EuroChem CTAC guide on how to assess the performance and to evaluate the uncertainty in qualitative analysis. And I would like to suggest you to wait a few more weeks and get that document, because I think this document will be a good balance between available tools and what can be done in the lab, and we'll also discuss difficulties of implementing some of that concepts. So I think that if you wait a few more weeks, you'll get a nice reference in this area.
Okay, I think most of EuroChem documents have this practical point of view, and they are not pure scientific, and they are very applicable in many laboratories. And I'm sure that your document in that working group will have the same feature that can be easily applied and practicable for the laboratories.
Yes, we hope. Although one of the problems in qualitative analysis is determination of false positive rates when the procedure is very selective, and some of the tools that are presented in that guide can be easily directly applicable. Others are a little more difficult, but we need to mention them. Yes, but I hope that this guide will help moving this discussion a little further to improve the status of qualitative analysis.
Okay, I'm finished with my question. Is there any comment from your side that you would like to add to our discussion?
No, but it was a pleasure to have this talk with you. I hope that this discussion will be useful for some people, and I wish you lots of success with this channel, because you are doing excellent work of disseminating these topics and discussing it.
Thank you very much, Mr. Ricardo. I'm very honored to have this. It has been a learning opportunity for me to have this talk with you, and I hope that this discussion would be also useful for our audience. Thank you very much for your time, and I hope that to see you again very soon.
Okay, so bye.
Thank you.
Thank
Bye-bye.
you. Bye.